Today we are going to derive the equation for a torque acting on a dipole due to an external electric field. So when an external electric field is present, actually what happens here is that the dipole, curiously enough, the dipole will experience two forces on either side. The positive charge will experience a dipole in the direction of the electric field, while the negative may experience a dipole in the opposite direction as well. So naturally, opposing forces on the same object create a torque. So opposing force on same object create a torque, also known as couple, because it's a turning effect, right? So since the torque is now created, let's now remember the fundamental equation of torque. So torque equation you would have learned, torque is R cross F or RF sine theta, where I just want to reiterate the definition. R is in fact the turning distance or the distance of separation here. So we have those values here. The distance of separation is given here, right? The distance of separation is given here. In fact, the distance is given as d, and the value of F is also given. Force torque is equal to F is equal to QE. We know the value QE is given here. Now whether it is plus or minus, in fact, is does not matter here, because I'm about to show you what the final equation is going to look like. So torque is equal to d times QE. Now d times QE multiplied by, you guessed it right, sine theta, right? So the sine of the angle is also important here in this equation. However, what we observe here is something interesting here happening. The product d times q is also called as the dipole moment. So that is matching with the formula for a dipole moment as well. Small letter p, d multiplied by q. So I can just combine them and I'll get my final equation. Torque is equal to Pe sine theta, just because the distance of separation multiplied by the charge of the one of the dipoles is equal to the dipole moment. And again, this is applicable as long as both the charges on the dipole are equal. That's why the derivation has plus q and minus q. Thank you, dear students.